Hey there, my name is Valdemar, and in this three-part video series we're looking at these three types of boxes that are typically used when recording guitar. Let's check it out. Today we're doing a deep dive into the DI box. A DI box takes your instrument as an input, usually a bass guitar or an electric guitar, and converts it into a signal that can be connected to a preamp or audio interface that's designed to accept microphone level signals. This can be useful in some scenarios, such as one where you don't have a proper instrument level input, or if you need to run a very long cable between your instrument and the recording device. Many DI boxes also let you tap the signal, providing this mic level output for recording, but also letting you route the original signal into an amplifier, so you can record the dry DI signal and use an amp at the same time. Well, let's take a look at how the DI box operates. I will again refer to Radial's website, where we can see a block diagram for one of their most basic DI boxes, which is a good starting point. I personally have this Behringer Ultra DI box, which operates very much like the Radial one. The signal enters the box and is fed into two parts. One part is routed back to the through output, sometimes also labeled a link output, and this is intended to feed the input signal back out so you can connect it to an amplifier. The signal goes through an optional pad feature which reduces the signal volume in case it's too loud for your recording device to handle. On my Behringer unit, this is labeled as attenuation, and it's common to find options for between 10 and 40 dB of attenuation on most devices. The transformer is where all the trickery happens. It provides several benefits which we'll break down and explain, but its primary function is to convert the high impedance, high voltage signal into a low impedance, low voltage balanced signal. That signal is then routed to the XLR output of the box, which you can connect to a microphone preamp. Let's think about why these features are beneficial for a moment. I covered the benefits of balanced signals in my first video about reamp boxes, but here's a quick recap. An unbalanced electrical signal is transmitted by two wires. One carries a reference voltage, which we usually refer to as ground, and the other carries the actual signal. It's the difference between these two voltages that represents the final signal that gets recorded or amplified. In contrast, a balanced signal is transmitted by three wires, the reference voltage, ground, and two identical but inverted signals. So what happens when electromagnetic radiation from electrical cables, cell phones, computer hardware, or transformers hits our unbalanced cable? The electromagnetic waves will induce a small current in the cable, and this causes hum or other unwanted buzzing. The electrical ground conductor has practically an unlimited ability to sink or source current because it's usually connected to a large reservoir of electrical charge, either the actual electrical ground in your house or your body as you are touching the strings of the guitar. The small current induced in the wire is simply absorbed by the large reservoir, while the signal wire has nowhere to move the additional charge, so it ends up flowing into the next stage of the signal chain. The balanced signal is much less affected by the electromagnetic radiation, because any radiation that interferes with our signal will affect both the positive and the negative phase of the signal equally. So when the signal is finally converted back to an unbalanced signal, almost all the noise is cancelled out, and we're left with only our original signal. Again, a very clever trick. This means we can run our cables much longer distances without being affected by electromagnetic noise. Guitar pickups can output a signal with a peak-to-peak voltage swing similar to that of a line level signal, but they are only able to create a small amount of current. In contrast, microphones create a very small voltage but a relatively strong current compared to guitar pickups. If your recording device or audio interface is specifically designed to accept microphone inputs, it expects the connected device to be able to provide this current, but a guitar pickup cannot. To overcome this, we need a transformer. A transformer can take a high voltage, low current signal and convert it to a low voltage, high current signal. In a DI box, we use a step-down transformer, so the output signal will have the same qualities as a microphone signal, ensuring it works well with our microphone preamps. You can think of the transformer working like a gearbox on a bicycle. In a low gear, you can pedal fast and there's little resistance, but you won't go very fast. In a high gear, you pedal much slower and the resistance is greater, but you can go much faster. In both scenarios, roughly the same amount of energy is used to go the same distance, but we may find it easier to use lower gears when going up hills, and higher gears achieving higher speeds when on a flat road. In this case, the gearbox is acting as a sort of mechanical impedance matcher. Similarly, we could liken a guitar signal to spinning fast in a low gear and a microphone output to spinning slow in a high gear. DI boxes were much more common before the home recording revolution, because almost everything was recorded using microphones into a big studio desk that was designed to work with microphones or line level signals. Usually, a DI box was only used to record bass guitar, which was often blended with the mic recording of the bass speaker cabinet for more clarity. Nowadays, more and more audio interfaces and mixers feature instrument inputs, dedicated inputs with preamps designed to work well with high impedance instruments. If you've got one of these in your recording interface and you're located less than 5 meters away from your interface, then there is absolutely no reason why you shouldn't use that and forgo the DI box completely. In a small home recording setup, a DI box offers no advantage over a quality instrument input. Hey, Future Valdemar here. I just watched the most recent video from Glenn, and he pointed out that there's actually quite a lot of audio interfaces out there that don't have very high quality instrument inputs, and are famous for having some pretty bad design flaws in my opinion, and they don't really do a good job of the task that they're intended for. A very famous example of this is the first generation of the Focusrite Scarlett interfaces, which completely failed to handle the signal from active pickup guitars because they didn't have the headroom necessary to record it. So this is definitely something I would put as a bit of a caveat on the advice I'm giving here. It's the fact that this is obviously only a good recommendation if you do have an audio interface with a quality instrument input. If your instrument input struggles to deal with the high dynamic range of a guitar pickup, then you may in fact be better off using a DI box. But hopefully, most manufacturers these days have sort of learned their lesson a bit, and they've actually started designing these a lot better than they were about 10 to 15 years ago. But it is something to keep in mind in case you do have an older audio interface. Back to the video. The scenarios where a DI box could prove useful is if you don't have the appropriate instrument input, if you want to split the signal so that you can record a DI track and plug into an amp at the same time, or if you're physically located far away from the recording interface. So, hopefully I've convinced you that you probably don't need a DI box. Remember, when someone tells you you absolutely need something, ask them to back it up with facts. Chances are good that they're just regurgitating old bro science off the internet with absolutely nothing to back it up. If something is said often enough, people tend to accept it as fact. Thank you so much for watching my video. I'll see you in the next one, and in the meantime, have fun making music.